Can nearby supernova explosions threaten life on our Earth? Earth's protective atmosphere has sheltered life for billions of years, creating a haven where evolution produced complex life forms like us. The ozone layer plays a critical role in shielding the biosphere from deadly UV radiation. It blocks 99% of the sun's powerful UV output, and Earth's magnetosphere also shelters us. But the sun is relatively tame. How effective are the ozone and the magnetosphere at protecting us from powerful supernova explosions, though? Every million years, a small fraction of Earth's 4.5 billion year lifetime, a massive star explodes with 100 parsecs, that's 326 light years from Earth, and we know this because our solar system sits inside a massive bubble in space called the local bubble. It's a cavernous region of space where hydrogen density is much lower than outside the bubble. A series of supernova explosions in the previous 10 to 20 million years carved out the bubble. Supernova are dangerous, and the closer a planet is to one, the more deadly its effects. Scientists have speculated on the effects that supernova explosions have had on Earth, wondering if it triggered mass extinctions, or at least partial extinctions. A supernova's gamma-ray burst and cosmic rays can deplete Earth's ozone and allow ionizing UV radiation to reach the planet's surface. The effects can also create more aerosol particles in the atmosphere, increasing cold coverage and causing global cooling. A new research article in Nature Communications Earth and Environment examines supernova explosions and their effect on Earth. It's titled Earth's Atmosphere Protects the Biosphere from Nearby Supernova. The lead author is Theodoros Christoudias from the Climate and Atmosphere Research Center, Cyprus Institute, Nicosia, Cyprus. The local bubble is not the only evidence of nearby core collapse supernova, SNEs, in the last few million years. Ocean sediments also contain iron-60, Fe60, a radioactive isotope of iron with half-life of 2.6 million years. SNE expelled iron-60 into space when they explode, indicating that a nearby supernova exploded about 2 million years ago. There's also Fe16 sediments that indicate another supernova explosion about 8 million years ago. Researchers have correlated that supernova explosions with the late Devonian extinction about 370 million years ago. In one paper, researchers found plant spores burned by UV light, an indication that something powerful depleted Earth's ozone layer. In fact, Earth's biodiversity declined for about 300,000 years prior to the late Devonian extinction, suggesting that multiple supernovas could have played a role. Earth's ozone layer is in constant flux. As UV energy reaches it, it breaks ozone molecules O3 apart, and that dissipates the UV energy, and the oxygen atoms combine into O3 again, and the cycle repeats. That's a simplified version of the atmospheric chemistry involved, but it serves to illustrate the cycle. A nearby supernova could overwhelm the cycle, depleting the ozone column density and allowing more deadly UV to reach Earth's surface. But in a new paper, Christoudias and his fellow authors suggest that Earth's ozone layer is much more resilient than thought and provides ample protection against supernovas within 100 parsecs. While previous researchers have modeled Earth's atmosphere and its response to a nearby supernova, the authors say that they've improved on that work. They modeled Earth's atmosphere with an Earth system model with atmospheric chemistry, EMAC, a model to study the impact of nearby supernova explosion on Earth's atmosphere. And using EMAC, the authors say they've modeled the complex atmospheric circulation dynamics, chemistry, and process feedbacks of Earth's atmosphere. These are needed to simulate stratospheric ozone loss in response to elevated ionization, leading to ion-induced nucleation and particle growth to CCN, cloud condensation nuclei. They said, we assume a representative nearby supernova with galactic cosmic ray GCR, ionization rates in the atmosphere that are 100 times present levels, they write. That correlates with a supernova explosion about 100 parsecs or 326 light years away from us. The maximum ozone depletion over the poles is less than the present-day anthropogenic ozone hole over Antarctica, which amounts to an ozone column loss of 60 to 70%, the authors explain. On the other hand, there is an increase of ozone in the troposphere, but it is well within the levels resulting from recent anthropogenic pollution. But let's cut to the chase. We want to know if Earth's biosphere is safe or not. The maximum mean stratospheric ozone depletion from 100 times more ionizing radiation than normal, representative of a nearby supernova, is about 10% globally. That's about the same decrease as our anthropogenic pollution causes. It would not affect the biosphere very much. Although significant, it's unlikely that such ozone changes would have a major impact on the biosphere, especially because most of the ozone loss is found to occur at high altitudes, the authors explain. But that's for modern Earth. During the Precambrian, before life exploded in a multiplication of forms, the atmosphere had only about 2% oxygen. How would the supernova affect that? We simulated a 2% oxygen atmosphere since it would likely represent conditions where the emerging biosphere on land would still be particularly sensitive to ozone depletions, the authors write. Ozone loss is about 10 to 25% at mid-latitudes and an order of magnitude lower than in the tropics, the authors write. At minimum, ozone levels at the poles, ionizing radiation from the supernova, could actually end up increasing the ozone column. So we conclude that these changes of atmospheric ozone are unlikely to have had a major impact on the emerging biosphere on land during the Cambrian, they conclude. What about global cooling? Global cooling would increase, but not to a dangerous extent. Over the Pacific and Southern Oceans, CCN could increase by up to 100%, which sounds like a lot. These changes, while climatically relevant, are comparable to the contrast between the pristine pre-industrial atmosphere and the polluted present-day atmosphere, they said. They're saying that it would cool the atmosphere about the same amount as we're heating it now. And the researchers point out that their study concerning the entire biosphere, not individuals, our study does not consider the direct health risk to humans and animals resulting from exposure to elevated ionizing radiation, they said. The researchers point out that their study concerns the entire biosphere, not individuals. They write, our study does not consider the direct health risk to humans and animals resulting from exposure to elevated ionizing radiation. Depending on individual circumstances, individuals could be exposed to dangerous levels of radiation over time, but overall the biosphere would hum along despite a 100-fold increase in UV radiation. Our atmosphere and magnetosphere can handle it, they said. And the authors write, overall, we find that nearby supernova are unlikely to have caused mass extinctions on Earth. We conclude that our planet's atmosphere and geomagnetic field effectively shield the biosphere from the effects of nearby supernova, which has allowed life to evolve on land over the last hundreds of millions of years. This study shows that Earth's biosphere will not suffer greatly as long as supernova explosions keep their distance from us. This is published by Universe Today, and this is on Science Alert by Even Go. Please leave your comments. Thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.